Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review of concepts from your trig class. As such, I do not delve into the proofs of theorems, nor do I go into excruciating details with examples. If you've never had a full course in trig, and you're currently in a pre-calculus course, I highly recommend watching my trig playlist on YouTube as it goes into greater detail with all the trig. Again, trigonometry is so important for calculus that having a shaky background in the subject will lead to abysmal results in calculus. With that said, let's just do a single example of how to identify the equation for a sinusoidal function given a graph. So here we've been given a graph of a function, and we're asked to find the function or the equation for this graph. There are a couple ways of doing this, honestly. First of all, you can see it's a sinusoidal function. It's either sine or cosine, and actually it's both. So you could have 10 students in a room and get 10 different answers, all of which are correct. I highly recommend using the given information. They gave you 2 points, pi over 6 comma negative 2 and 7 pi over 6 comma negative 4. Now, how you use those points is up to you. Personally, I would probably consider this an upside down sine function, starting at pi over 6. However, some people will consider it an upside down cosine function starting at 7 pi over 6. That's fine too. But personally, again, I just start with the initial point they've handed me and then say, okay, well, what's the trig function from that point forward? Okay, it's a upside down cosine. There's all different ways they can hand this to you, but they could have, let's say they didn't give you this point. Let's just scratch that out. Let's pretend they didn't give you that. They could give you this point up here. Let's pretend that they did that. Then they've given you a maximum and a minimum. In those cases, it's much easier to use a cosine curve because given a maximum and minimum, you can easily compute the midline, and then you can compute the period because you have gone through half of the period going from the low to the high. So again, those are all just pieces of advice, but let's go ahead and tackle this. I know it's an upside down sine function, so I'm going to maybe right over here, in fact, I'm going to write this as y equals a negative a sine of bx plus c plus d. And now I'm going to draw on this where the midline is. They didn't explicitly state the midline, but they implied the midline occurs at a height of negative 2, halfway between the maximum and minimum. So let me grab my ruler here, and I'm just going to go ahead and draw in a midline in green here. I think that this is it. Oops. All right, so that I think is the midline. So let's go ahead. Let me turn that ruler off. I don't need it anymore. Let's go ahead and label that midline. Y is equal to a negative 2. And that allows me to state what D is. D is how far the curve has been lifted up or shifted down, and it's been shifted down 2 units. So this is now negative a sine of bx plus c, and then minus 2. Now what I need to do is probably find the amplitude. That's the next easiest thing. The amplitude is just the distance between the midline and the maximums or the minimums. It's the same distance no matter what. Notice the midline is at a height of negative 2, and the minimum is at a height of negative 4. That's a distance of 2. Or you could have done it this way. The midline is at a height of negative 2, and the maximum looks like it's a height of 0. And so again, that distance is 2 in either case. So I know the amplitude is 2, so now I know it's a negative 2 sine of bx plus c minus 2. The next part throws a lot of students off. We need to talk about how far it's, or what the period is. Maybe I should start there. We need to talk about the period of this function. Now, I do want to state very, very clearly, b, this b over here, is not the period of this function. Nor it is not the period of any trig function. It's associated with the period of the trig function, but it's not the period of the trig function. That's critical to note. All right, let's see. In fact, let's just state what it is. The period is actually 2 pi over b. So that's important. So let's see if we can figure out the period of this function. In other words, how long does it take to get from beginning to ending? Well, that's going to be kind of challenging if we compute from beginning to ending. However, it won't be so bad if we compute how long does it take to get from beginning to 1/4 of the way through. That's 1/4 of the way through. If you think about it, here's the second quarter, here's the third quarter, here's the fourth quarter. So we have gone by, let me see if I can erase this without erasing my trig function. I don't even know if I can. There we go. We've been given 1/4 of the period. The distance between pi over 6 and 7 pi over 6 is 1/4 the period. So again, 1/4 of the period is what they've actually showcased to us is the distance between 7 pi over 6 and the angle pi over 6. These two values right here. And that's going to be 6 pi over 6 or pi. So therefore the period, if you multiply both sides by 4, is 4 pi. Now that I know the period, that it takes 4 pi to go the full length of that, I can then use it in this formula. The period, which we said is 4 pi, should equal 2 pi over b. Multiply both sides by b and divide both sides by 4 pi and you'll get 1/2. So b is 1/2. So now I go back over here and say, okay, this is a -2 sine of 1/2 x plus c minus 2. So again, my critical warning is b is not the period. It is associated with the period, but it's not the period. It's associated to the period via that relation right there. Finally, c. Again, I'm going to make a little note here. C is not the phase shift. It's related to the phase shift, just like the period is related to b, but it is not the phase shift. The phase shift is equal to -c over b. And we happen to know what b is, because we just computed it, and the phase shift is where you start graphing. This is the phase shift right here. So our phase shift is pi over 6. That's where we started graphing. That's the x value for the phase shift. So our phase shift is pi over 6, and that should be -c over b, and b is 1/2. In other words, pi over 6 is equal to a -2c. Divide both sides by a -2, and you'll get a pi over 12 is equal to c. And now I have the full trig function. It is -2 sine of 1/2 x minus pi over 12, and then minus 2. That is that graph right there. Step by step, done. So it is very, very important to remember, again, that B is not the period and C is not the phase shift. A lot of students will make that mistake. But by the time you hit pre-calculus, you shouldn't be making that mistake anymore. I hope this video was helpful for you. I know it was only a single example, but again, it is assumed that you've had full trig class. So hopefully this was okay for you for a review.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.